welcome. In this video, I'm going to be verifying the formulas for the derivatives of inverse sine and inverse cosine, right? And we know that they look kind of weird, and it's like, why is this the case? This doesn't really seem to have anything to do with trigonometry. And so what I'm going to do is I'm going to go through, I'm going to take the derivative, and I will draw you the pictures. Okay. So for right now, I'm going to start with y is inverse sine of x. That means that x is equal to the sine of y. That's going to be big. And then if two things are equal, then their derivatives with respect to x will be equal. So I'm going to take the derivative of both of these things. And remember, eventually I'm hoping to find dy dx, right? So I can take the derivative implicitly, and I'll be able to go over here and I'll say that the derivative, well, I guess I'm going to just say that the derivative of these two things are going to be the same. And so that means the derivative of x with respect to x, that's going to be 1. And then the derivative of sine y is going to be cosine y dy dx. Okay? So if I can solve for dy dx, it's going to be 1 over cosine y, but it's like, oh, that's not as good as I'd hoped because this is not the formula. Okay? So where is it? Yeah, here. Dy dx is equal to 1 over the cosine of y. Okay. And now what I'm going to do is, box myself in here, I'm going to draw a large triangle diagram. And I think what I might do is I might go over here and, yeah, just do that. It's nice and large for us. All right, here is my triangle diagram. Now, I think, you know, the easiest right triangles to consider are going to be the ones where the hypotenuse has length 1. So I'm going to assume that. But let's just say x is the sine of y. Well, sine, we take the sine of an angle. So that means that y needs to be the arc whose sine is x. And sine is opposite over hypotenuse. So I'm going to label that as x and 1. Why is the arc whose sine is x? Yes. All right. Now, that means that this thing right here is going to be the square root of 1 minus x squared. You can check that for yourself, but if I squared that and then added it to x squared, I would have 1 squared. And then realize that the cosine of y in this case is the square root of 1 minus x squared divided by 1. So I've got dy dx is 1 over the cosine of y is the square root of 1 minus x squared, and that's why the derivative of inverse cosine is this 1 over the square root of 1 minus x squared. All right? Derivative of inverse sine is inverse cosine is going to be very, very similar, and so I'll maybe go a little faster through that. You know, I'm going to start by saying y equals inverse cosine of x. So x equals the cosine of y. I'm going to take the derivative of both sides with respect to x. So okay. And then when I take the derivative of cosine of y, that's going to be negative sine y dy dx, and that's where we get that negativity from. So 1 equals negative sine y times dy dx. Meaning that dy dx is negative 1 over sine y. So you can see it. Now again, I'm going to need to draw myself a diagram. And kind of box myself in. So maybe I'll just go and I'll just clear all this off. You saw this, I proved it for you. Myself a large right triangle diagram. All right. Y is the arc whose cosine is x. Okay, so y is the arc, cosine is x over 1. Okay, cosine being adjacent over hypotenuse. means that this is, again, the square root of 1 minus x squared. So the sine of y is 1 minus x squared, square rooted, divided by 1. And so I've got dy dx is negative 1 over that square root of 1 minus x squared, which is what I had hoped to show you in the first place.